Hello, my name is Chris Allen, and I would like to share with you my Calc BC final project on infinite series FRQ. So the stem for my question is as follows. I guess I should note this was required to be no calculator, so it's no calculator. But I gave the Maclaurin series for the function w of x, and it's given by the following: the sum from 0 to infinity, negative 1 to the n over 2n plus 1, x to the 2n plus 2. So that, when expanded out, gives us x squared minus x to the 4th over 3 plus x to the 6th over 8. That's minus, x to the 8th over 7, etc. A little bit more about the series. So first of all, I'd like to point out that this is a series, and this particular problem is x squared. I just read that to you, is very similar to the following series. So this is how I came up with this. So I looked at the infinite series for arctan, which is x minus x to the 3rd over 3. And as you'll notice, the only difference between that series and the one that I'm using is that I multiplied it through by a factor of x. Here's what the graph of this function actually looks like. So again, this would be the function y equals x cotangent x. Anyway, so that's how I built it. So for my first question, part A, determine the radius of convergence for the Maclaurin series. So what the student needs to do first is they need to set up the ratio test. So they need to let the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. That needs to be less than 0. So here we go ahead. Student should compute that limit of the ratio test. And when they get that done, they get down to this last step, which will give you x squared. And we need that absolute value to be less than 1. And so in this case, we're basically talking about the radius of convergence being 1. So they get a point for setting up the ratio test, a point for computing the limit correctly, and then determining or stating the radius of convergence. So that's 3 points for that part. Part B is to determine the interval of convergence for the Maclaurin series. Now notice in this previous one, we did the radius of convergence. Here we're doing the interval of convergence. So here, this one's out at 2 points. So first things first, they need to substitute negative 1 in for x, which will give them the series stated there at the top. And then they have to use the alternating series test to show that that converges. And then when they put x equals 1, that reduces to the same case as above. So that also is going to converge by the AST. And so the radius of convergence here is, the interval of convergence is negative 1 to 1, including negative 1 and 1. So they get 1 point for using the alternating series test, and they get 1 point for stating the correct interval of convergence, 2 points. Part C, write the Maclaurin series for W prime. So that's kind of the big idea with all these infinite series, is that you can take, in this case, a trigonometric function, and we can write it basically as a polynomial. And so what we're going to do here is to find W prime. You're just going to use your power rule for differentiation, and you'll get the following series. So there's the general term for W prime. And then the first 4 terms are 2x minus 4/3 x cubed plus 6/5 x to the 5th minus 8/7 x to the 7th. Those are the first 4 terms of W prime. So I'm giving this particular problem 2 points. 1 point for the general formula for W prime, and then 1 point for the first 4 terms of W prime. So a student could actually just get the first 4 terms by doing the derivative of the first 4 terms of the original series. But to get the second point, they have to have the general formula. And then finally here, part D for the Maclaurin series. So here it says the Maclaurin series for e to the x is, and that's provided, and it says write the 5th degree Taylor polynomial for q of x, which will be equal to e to the x w of x. So w of x was this algebraic times a trigonometric polynomial. So it's x times arctan of x. Now we're going to multiply it by e to the x. So this is the product of another, a transcendental function, e to the x. So in essence, we're just going to take the Maclaurin series for e to the x, which is 1 plus x squared over 2 factorial plus x to the third 3 factorial, blah, blah, blah. And then we're going to have to multiply it by our Maclaurin series for this particular function w of x. And so when we multiply that, you actually got to multiply similarly that you would like if you were going to take a polynomial times a polynomial. So you have to go term by term. And through multiplication, you will find that the answer here for the 5th degree Taylor polynomial or Maclaurin polynomial, either way you want to word that here, would be fine, would be x squared plus 3x, x squared plus x to the third plus x to the fourth over 6 minus x to the fifth over 5. I'm going to give them 1 point for the first 2 terms because those are pretty simple to find. But to get the second point, they have to get the last 2, which are a little bit trickier and a little bit more subtle, particularly that x to the fourth over 6. So, and that is that. Thank you guys for your attention.